Thank you very much. So let's jump right into this thing. From a technology standpoint, when we start talking about smart use cases, IoT, those types of things, there are a number of different aspects that have to come together to make these things work, right? But conceptually, they're all very similar, regardless of what industry you're in. The idea is I've got some scenario, I need to gather some data or generate some data that comes from some things. I need to connect to these things to get the data. I need to analyze that by using some type of AI capabilities. And when we're talking about AI, people tend to use that term very generically at a real high level. You know, it's important to understand there are different types of AI, different capabilities, different approaches. Models and algorithms that are designed to work on weather data, for example, are not necessarily going to give you the insight you're looking for from traffic data, right? So I need to make sure I have the right tool for the job, apply some AI, I get some type of insight, some type of output that I'm looking for, and I use that to make a decision, right? I either want to automate something or I determine that something has happened, I want to notify somebody. But conceptually, that's how these things work. Gather the data, analyze the data, make a decision. In this space, there's a lot of talk about computer vision, right? Being able to do video analytics, the ability to analyze in real time a scene and determine what's happening in that space, what's not happening. There's something that should be there, there's something that shouldn't be there. That's a very, very powerful tool. So that comes up a lot in this space. Whenever we talk about video analytics, the idea of privacy comes up a lot, right? Facial recognition versus facial identification. So, you know, keep in mind when you're having those conversations, one, understand the laws, right? What are the rules and regulations around privacy in the state or for the industry or the spaces that you're in? But also think about it in terms of understanding the capabilities of the technology that you implement, right? So in some cases, I can recognize a face, right? Create a record of that face, apply that to my system, and then give that person all of the access or whatever it is that they're able to gather in that scenario without identifying who that person is, right? So that's one way to mitigate some of those scenarios. In other cases, I need to identify who that person is, and so again, make sure we understand what the rules are around that. In many of those scenarios, you need to opt in, all right, or you can opt out. Again, it depends. In some of the technologies, you can blur out faces. So when you're doing video analytics in public spaces and capture faces of minors, for example, right, the minors can be blurred out. So, you know, those are some things that come up in the whole video space. The other thing that comes up here will be digital twins, right? Heard of digital twins? Okay. Digital twins are applicable in this space. That's a whole different conversation. All right, so it's out of scope for today's conversation, but it will come up. If you'd like to talk about it offline, I'd be happy to drill into that. Or when we have Q&A period, if you got some questions, I'll field them as we can. Okay, so technologies that come to bear in this space. However, it's not about the technology. Okay, it's not about the technology. We get too hung up on I got to use AI for this, or I got to figure out what to do with my data, or I got to do all these other types of things. It's not about the technology, okay? I don't want you to think about that. What it's about is the impact, right? And I'll give you an example. A few years ago, I met with a mayor of a large US city. At that point in time, they were #1 for pedestrian fatalities in the United States. The mayor looks at me, we have the meeting, he says, I need that number to go down. That was his problem statement, okay? He said, people are dying, I need it to stop. He didn't say anything about data, AI, technology, none of that stuff mattered. It was the impact that he was looking to drive in that scenario. So that's what I want you to think about. Don't think about the tech, think about the use cases that we can apply to have the impact that you're looking for in the scenarios that you're responsible for. You got that? You sure? Okay, so let's look at the first space here. I'm in Detroit, let's talk automotive. Areas that we can impact. Loss of life, safety, unsafe conditions. Now, by no means is this unique to Detroit. Okay, this happens all over the country, all over the world. right? And it's not unique to the automotive industry, right? Industrial settings, manufacturing, they all deal with these same types of issues. But you may have figured out by now, these are local stories, and they're not that far off, okay? So let's talk about how we can impact the things in this space. This is my overview chart, okay? It's very dense, there's a lot of words, it's like that on purpose, okay? Somebody said early in my career, don't put too many words on your slide because your audience will read the slide and they won't pay attention to what you're talking about. That's fine, read the slide, okay? It's dense because there's a lot of opportunity in these spaces. All of the different, you've heard that term, the art of the possible. There's a lot possible in these spaces when we start looking at use cases and what we can do. Okay, so this is my overview for worker safety. I'm not going to drill into this. We don't have time to do that. Again, if you'd like to talk about offline, I'd be happy to do that. But we look at some of these things, monitoring fatigue, posture analysis, right, safety analytics. So let's drill into the worker safety space, right, and the use cases that we can do to have the impact in that space to get away from some of those bad headlines that we've seen before. Again, using video, sensors, wearable devices, right? I can determine what's happening in the environment, right? So are my workers in the space working within the confines of the spaces that they're supposed to be, right? As same for the robotics and the vehicles, the autonomous vehicles and all those types of things, making sure that the two don't come together where they shouldn't. Now, quick concept here. Prevention versus detection, okay? We get a lot about detection. I detect something happens. That's great. Something happened, I want to know. But I want you to think about prevention, right? If I detect something, the incident's already happened and the bad stuff is in the press, okay? Think about utilizing the capabilities to prevent those things from happening in the first place. So my video analytics does scene analysis. It anticipates this person is getting closer and closer to the edge of where they're supposed to be, okay? I'm going to anticipate or predict that an event might happen in that space. So now I can send an alert, I can slow something down, I can let somebody know, I can send a buzzer on the employee, get back to where you're supposed to be. Those are the types of things that can be done in this space. I can use the video to detect fatigue, right? Is the worker using the tool the way they're supposed to be using it? Lift with your legs, not with your arms. All those types of things can be programmed into these models in order to keep folks safe. Okay, where is this working? So Ford has these exoskeletons that they've been rolling out for several years now. Not quite on topic, but I love them. I think they're really, really cool, and if I could get one, I would buy one, and I would use it at home to do all the things that I have to do. But you can gather a lot of data from these things in terms of the impact that it's having on the workers, the time that it's taking to do the jobs. Can I adjust that in some of these tasks, right? The impact that it's having in this space. It seems to be real successful because they continue to roll these things out. GM has built a digital twin for many of the spaces that they're responsible for, right? And they're doing a lot with this digital twin, but from a safety standpoint, what they can do is they can run simulations, right, as they want to tweak the times for different tasks in an assembly line of tasks. If they want to move equipment around and look, well, can I put this piece of equipment here? What are my clearances? They can run all those different types of simulations to make sure that they're not creating any safety issues that they didn't have before. Or they can look at their current environment and uncover any potential safety issues that they might have that they didn't see before. And that's what they're doing in that space. Stellantis has this VR lab, and what they do is they train the workers on how to utilize the tools and do the jobs within the spaces that they're in VR. So now I know this is how much space I have to use, this is how I have to use the tool, this is how I can work in this environment and maintain the safety, right? So some things that are happening in this space. So before we move to the next space, questions, comments, thoughts about worker safety? Okay. Healthcare, patient safety, acquired conditions, staffing. Again, local headlines, fairly recent, things that you can impact. Don't want to dwell on the bad stuff, let's talk about the good stuff. There's my overview chart for Patient safety. Now, healthcare is an interesting space because when I start looking at the whole art of the possible and all the different use cases in that space, there are different segments that we could look at. If I just drill into patient safety, I've got smart spaces, risk prevention, hospital monitoring, predictive analytics, a lot of things I can do in this space. Again, read through it for a little bit. We're not going to dig into this. I can share it with you afterwards if you're interested. If I look at risk prevention, the whole fall protection or fall prevention is huge in this space, right? So being able to have smart spaces, smart devices, and hospital rooms are a really good example of smart spaces. There's a whole lot of AI, IoT, and compute going on in that space. So the ability, again, use the sensors, use the video, those types of things. Where is the patient? Are they somewhere they shouldn't be? Are they trying to get up when they should not be trying to get up? Are they getting too close to the edge of the bed? Those types of things, right? And again, there's not human beings watching this, right? The video is being analyzed by the system. The system will alert the staff, hey, we have a potential issue, let's go prevent the fall. From a deterioration detection standpoint, lots of data being collected on my patient in real time. So I have the ability to take all of these different things, breathing rate, heart rate, is the person restless, all those different types of things that we're monitoring, and determine or predict, hey, a medical event is about to happen, okay? Based on this person is sweating, the temperature's rising, there's a whole bunch of things happening, I need to alert a staff person, something is about to happen, here's my best guess at what I think it's going to be, the degree of accuracy is really, really high. Again, prevention around patient safety so things don't happen and they don't get detected. The infusion, so smart pumps, right? So a regular pump will disperse the amount of medicine that you tell it to for as long as you tell it to disperse. A smart pump understands and recognizes the medicine that it's administering. It also understands and recognizes the medicine that it has already given to this patient. It has the intelligence to say, hey, these two might not match, there might be an issue here, let me alert somebody. Okay? A smart pump has access to the medical records of the patient, and it can determine, hey, 3 years ago, this patient had an allergic reaction to this type of medicine. Okay? Stop and alert somebody. It might recognize, based on the height and weight or some other information, this is not the right medicine I should be giving to this person. Okay? So it's a level of protection to circumvent human error in this space. Right? And human error happens in this space. It's what happens. It has adverse effects on people, lawsuits, all those kinds of things. A smart pump can help alleviate that, right? In terms of the use case. Let's see. Determining if there are things in the air that shouldn't be and patients moving around. I've got an example for that one. So Mount Sinai, the real-time location system is nothing new. It's being used for asset management. Asset management in medical situations is a really, really big deal, making sure that the pumps and the wheelchairs and the other things are where they need to be, when they need to be. And in the past, staff has been guilty of hoarding those types of things so that they can have them when they need them to have them. So they've put a lot of tracking systems in. But at Mount Sinai, they also use it to track the patients, and they use it to track the staff. So for patients who are allowed to move around, I can monitor that patient's location in real time, 24/7, to make sure that they're not somewhere they shouldn't be, not headed to the stairs, they're not stationary in some place that's not their room for too long. Anything that might determine that there's an issue that I can alert somebody to say, hey, go check in on this situation, right? So we don't get somebody lost in somewhere they shouldn't be. The tracking of the staff is mostly for a utilization standpoint, right? A staffing standpoint, making sure that there's coverage where it needs to be, when it needs to be, the right people, the right number, the right skill sets, right? And I can do that by, anonymizing the data. I think I said that right. Staff person one, staff person two. I don't need to identify people. I'm not trying to call people out, right? I can do that if I need to, but basically it's about making sure that I've got the resources where they need to be. And they can do that using their tracking system. McKenzie Richmond, they got the smart beds, right? So the beds, it tracks 35 different data points. How you're laying there, or you're moving around, or you're sitting up, should you not be sitting up. It also has the capability to do audio analysis, right? So if the patient is speaking out or moaning or something like that, it can determine based on the audio analysis if that person's in pain, if that person's under duress, right? More information that I could use to say, okay, I think I got a situation here that I need to alert the staff about. So that's what they do with the smart beds. The other thing they can do in a hospital room with the audio is the temperature and environmental controls can be controlled by voice, right? So instead of calling a staff person or a nurse, hey, can you turn the temperature up, can you turn it down? The patient can do that using the voice and just get it just right. So those types of things are also being implemented. At Johns Hopkins, they got issue, well, it's not just there, but sepsis is an issue from a detection standpoint because the challenge is a lot of the symptoms of sepsis, I think I'm saying that right, are similar to other conditions. So a lot of times it gets misdiagnosed, and time is of the effort as the essence when you're dealing with this from a treatment standpoint. So they built that deterioration system specifically looking for, is this sepsis or not? And we want to know as soon as we can so that we can get involved and prevent them. Okay, so patient safety. Comments, questions, thoughts around patient safety? Yes, sir. There's a microphone coming.
In automotive, as an example, we spend a whole lot of time on what we call failure mode and effects analysis. What could go wrong? How severe is the penalty going to be if something goes wrong, and what do we do to prevent it? So in a lot of these technologies, my first gut reaction as an engineer is, oh, what if this fails, then what?
So everything can go wrong, right? Anything can go wrong. And that's part of the challenge that we have in this whole AI bubble. And unfortunately, what we see is the rules don't change, the laws and legislature, they catch up after something bad has happened, right? So one of the best things I would say is you start small, right? Eat the elephant one bite at a time. Start small with controlled scenarios where you understand your data inputs, you understand exactly what you're looking for in the output. Because sometimes AI will give you the answer that you want versus the answer that's the truth, right? So you really have to put a lot of controls around that. In terms of your test cases, in terms of making sure that you're applying the right tools to it and getting what you're looking for. The other thing that makes a big difference is your training data, right? Your model is as smart as the data that you feed it with. So you want to make sure that you've got a diverse set of data. You want to make sure that you've got data that represents all the areas that you're responsible for to make that model as smart as you can. And if you work in this space from a development standpoint, there's a concept of continuous improvement, continuous development. It's a loop, right? So I want to make sure that I'm always testing my model, I'm always updating it, I'm always tracking to the outputs I'm looking at. Those are just best practices. By no means does that guarantee that something might not go wrong. The track record is pretty good. It's kind of like air travel. Right? Air travel is the safest way to travel, but when something bad happens, it's really bad and you hear about it a lot. So that's probably the best I can give you in that space. There's another question? Yes, sir?
So a couple of slides ago, I was just curious about patient elopement. What was that?
That's the patients moving around and trying to leave when they shouldn't be. Right? So
Just leaving the hospital or just walking out of the room?
either and or both. Right? If I got patients, in some scenarios where there are mental issues, right? Patients want to try to leave, or they think they can leave, or they don't want to stay, or they think they're being held against their will. There's a lot of different scenarios. But the idea is I need to make sure I know where this person is, and if there's a high risk of something like that happening, I can use the technology to make sure I don't lose them. Okay.
I have a question.
Yes.
So I love the healthcare scenarios that you talked about, but I think from the cybersecurity perspective, how big of a target that puts on the environment. Can you talk to that and what people are doing to address it?
Can I come back to that?
Sure.
I got a space for that.
Okay.
Okay. All right, so I'm going to move on to the next one, and then we should have time at the end for additional questions. I appreciate the questions. Traffic safety. My research tells me that traffic is an issue in Detroit. Yes? No? A little bit. Okay. Again, unique to Detroit? No, absolutely not. But there's some things that can be addressed, right? There's some impact that can be had, some use cases that can be applied in this space, right? And the data shows that when the traffic is moving efficiently and it's moving cleanly, there's less likelihood for accidents. So, my overview chart. Connected vehicles, hazard detection, crash analysis, smart infrastructure. There's a lot of ways that we can go in this space. And let me point out this. These overview charts, these are not complete lists by any means. I just picked out some of the highlights, some of the heavy hitters of things that can be done in this space. But these charts are not complete lists. There's a whole lot more that can be done. Again, see something you like, we can talk about it. Maybe I'm missing something, you can educate me on some things that, that you've seen that I don't have here. But if we drill down, monitoring and hazard detection. Again, video huge in this space, right? Cameras all over the city, cameras at intersections, and I can analyze that video to find vehicles going the wrong way, speeding, reckless driving, lane shifts, weaving, you name it, right? I can figure out what it is. Now, I can take that information about that scenario, description of the vehicle, make, model, color. I can read the license plate, so I can tell you who I think is driving, or at least who's registered to the car, where they're headed. Send all that information to the proper authorities, right? So state troopers, the local cops, first responders. Now they understand there's a situation happening. They can converge on that situation in real time. So hopefully those things can be put into place. Violations, pedestrians. So I can use the video to look at an intersection, and this is what we did for the mayor in the other city, to determine what the pedestrian traffic is crossing the street. So for example, if there's a person in a wheelchair or some other assisted device, right? That's, I'm 3/4 of the way through the intersection, the light's about to turn green. The system can dynamically extend that light so that that person has enough time to get across the street, okay? So now you can imagine if my lights have the ability to do that dynamically, they gotta be in sync, right? Because I can't have them all doing their own thing and then I throw off the flow of the traffic. So that's one of the things I can do from a pedestrian standpoint. Near misses. So near misses are really, really big in this space. It's something that's ramped up over the last several years. So I can have an intersection and never have any accidents, but that doesn't mean it's safe, right? So the video has the capability to analyze the trajectory of the vehicles or the people or the bicycles, or whatever it's looking, and determine, okay, in a slightly different circumstance, maybe under different weather conditions, that would have been an accident, right? So I can gather data around near misses and do analysis about intersections that we need to make some changes here before something bad happens. Okay, so the whole near miss calculation is something that's ramped up, and it's being utilized from a video standpoint. Okay, where are we doing this? Hometown, modes. Anybody heard of modes? Nobody? Okay, good. We can educate you here. So the mobility optimization through data equity and safety. So there was a huge grant, started rolling out this system. And modes is working to implement a lot of things that I talked about. But what I found interesting about modes is one of their targets is underrepresented communities, right, or historically disadvantaged communities. So from an impact standpoint, they're looking to address the traffic issues, but they're also looking to address it in places where those issues have not been traditionally addressed in the past. So kind of a double layer from an impact standpoint. It's not that interesting. Pittsburgh is my hometown. I'm from Pittsburgh. We've got the smart spines connected traffic signals. So there's a heavy corridor, it's about 135 lights. It uses the video and the sensors to monitor traffic. So how many cars, types of vehicles, buses, cars, bicycles, how fast are they going? It takes into consideration the weather conditions and the road conditions, right? And the signals will dynamically adjust the ebb and flow of traffic to keep it moving. Again, they're all in sync, right? So there's a layer of technology of analyzing the traffic. There's another layer of technology that says, let's keep all of these things in sync so I don't create any bottlenecks artificially. The data shows that when the traffic flows, people get to where they're supposed to be faster, and it's a lot safer. There's a lot fewer accidents in that space. So looking to roll that out in additional spaces. In Vegas, they're doing a similar thing. But what they've done is they've implemented it in where they call their medical district, right? So there's like a 20 intersection block that in the center is their huge trauma center, right, that they have in Vegas. So one, they're looking at it from a traffic management, traffic safety standpoint, but they're also trying to focus on how do we get emergency vehicles out and back as quickly as possible and as safely as possible. So again, somewhat of a double layer from an impact standpoint, address the traffic, but I'm also trying to maximize the outcomes for the patients, right? Time's of the essence when I'm dealing with these types of scenarios, so they get in and out safely and they can get the treatment that they need. So that's what's happening in Vegas. So, comments, questions, thoughts, traffic safety, or we can go back to any of the other ones if we didn't have time for those earlier. Okay. Critical considerations. So cybersecurity question that comes up. I know that you know that security is important. I get that. We get that. But I cannot overemphasize it enough in this whole AI, IoT thing space, okay? When I start connecting hospital beds and traffic lights and parking meters and you name it to the internet so I can gather data so I can do the things I need to do, I'm opening up big holes for the bad guys to say, come hack me, because I got a new device that's not an IT device, it's not locked down, it doesn't have any of the safety capabilities that are built into our traditional IT devices, right? So there are a lot of tools out there, there are a lot of ways to secure these devices, lock them down, the platforms that have to connect to them to get that data, the AI models that are running, all of those things can be secured. You have to make sure that you're thinking about that in the early stages before you start designing or putting anything in place. It gets missed in the non-IT spaces because it's not emphasized as much. So I cannot overemphasize the importance of making sure that you've got security and the cybersecurity tools laid over in these environments. So does that address the question?
Wondering if we'll see more of that type of attack based upon all this additional data that's being.
Oh, absolutely. It's happening now. You're just not hearing about it as much. And also, you know, the paydays from a device standpoint. Well, I take it back. When you hear about the incidents that happen, you know, the utility grids, the financial institutions, some of the other spaces, they don't really talk about how they got there. Right? You hailed it, Citibank got hit. Okay, well, they didn't tell you the Citibank got hit through a thermostat. Okay, so, you know, the bad guys are finding those ways, and it's there, it's happening now. There's just not a lot of emphasis on those types of things. But the idea is Citibank needs to go back and say, okay, what do we have on all these places from our AI use cases, and what devices do we need to lock down because we haven't? So you will see it, it's here, it's gonna get worse, it's gonna get better. You know, the bad guys are well-funded, they don't sleep. They're really, really smart, and it's an arms race that we go back and forth on. So that's why I wanted to emphasize that point, to make sure that you take those things in consideration when you start looking at rolling out these types of use cases. Okay. The ecosystem is critical here. So smart technology, smart use cases, it's a team sport. Because there are a lot of different, like I said in the beginning, a lot of different capabilities that have to come into play here. I've got the infrastructure, I've got the things, those things have platforms, they have makers, I've got the data pipeline, I got to move that data, right? I've got the security layer, you know, all of those things have to come to place from an entity standpoint. When I'm talking about doing my designs, doing my strategy, understanding who's responsible for what, the interoperability of that system, right? So understanding that ecosystem, who the players are, who you want to work with, that thing's very, very, very critical. One example, with the computer vision, right? Boatload of vendors in the computer vision space. They will all tell you, oh, we did everything great, right? The reality is, you know, some are really good at identifying vehicles, some are really good at identifying packages, some are really good at identifying, you know, scenes. These two people are happy to see each other versus they're fighting. So it's important to do that homework or work with somebody who's done that homework, right? To identify the partners and players that you want to have when you pull that solution together, and then being able to integrate them all together from an ecosystem standpoint. So think team sport, right? This is not a, you're not going to get all of this from one place, right? Whatever vendor comes up and says, yeah, we can do all of it, well, maybe they can, or maybe they got a good ecosystem. Ask those questions, right, to make sure that you understand who you're dealing with and what you're dealing with. And then there's funding out there available. You know, depending on your sector, depending on the use case, depending on the impact that you're trying to have, you know, there's state and federal monies available to help you move some of these things along. So look into that, or hire somebody to look into that for you, because there are monies available to help move these things forward. And with that, I ask you, what is your impact? So for the spaces that you're responsible for, right? What are the outcomes that you're looking to have? What is it you're trying to change? What are you trying to address? What are the use cases that we can bring to bear to do that? That's what I want you to think about and take away from this. So thank you very much. I appreciate your time. We've got time for questions, comments, thoughts, if there are any more in the audience. I did a really good job. No questions. I got one. Yes, ma'am.
So, do you see any opportunities to work across industries? Because we're not competing, especially like automotive to healthcare, but I see a lot of similarities like temperature anomalies. Let me throw that one out there.
Yeah, so there are horizontal solutions that work across industries, right? And I don't know if it's so much the industries working together, but there are examples of that depending on the space. But like I said in the beginning, a lot of the approaches and a lot of the concepts are the same, right? If I'm doing environmental controls dynamically in a building, right, with an HVAC unit that's capable of recognizing, utilization in a room, raising loaded temperature, that translates to a hospital, that translates to a bank, that translates to a stadium, right? Those types of things. Safety and security comes up all the time, right? So the ability to be able to use those technologies to determine if there are bad actors, to determine that something might happen in this space, that's across the gamut from all those different types of things. One of the challenges I have in this space from a working together is that industries and even segments within industries are very siloed, right? Nobody wants to share their data, right? And that's an issue because being able to do that cross-analysis from an AI standpoint really opens our eyes to insights and things that we hadn't seen before and would not have thought of. So trying to have some of those conversations. But the challenge is these are not off-the-shelf cookie-cutter type implementation. Okay, this is not for those salespeople in the room, this is not a t-shirt size type of scenario, right? The same use case from one scenario to the next, even in the same industry, could be radically different based on the factors involved, the data that we're collecting, and the outputs that they want to have. So that's something I try to take, help people understand. Well, we did it like this here, yeah, but that doesn't mean it's going to work like that there, right? So we got to start from scratch. Ask the right question, not necessarily from scratch, because there's a lot of intellectual capital that can be reused in this space, but in terms of your approach and what your final solution looks like, it could be different. So hopefully is that, okay, thank you. Another question, yes, sir?
Behind you.
Are you seeing any of the equipment manufacturers with IoT type devices beginning to standardize so this interoperability doesn't continue to be an issue? So for example, in healthcare, of all the different types of potential IoT devices, they're running on different types of technology and so on and so forth. So are you seeing them gravitate towards some sort of standardization to ensure interoperability?
Unfortunately, no. So, but where the standardization takes place, what I'm seeing are platforms designed to talk to those devices. Right? So there are vendors out there that will build IoT platforms that can connect to and gather data from devices no matter what that device is. And that's where the standardization layer is coming into place. Because when you look at the scenario, it's really, we can't drive that type of behavior, and there's really not a whole lot of incentive for them to do that. But the platform, the intelligence layer, that's where you'll find that. And that's what you should look for in terms of being able to find something that works across all the different devices in your environment, especially if you've got a lot of disparate devices. In some cases, that platform can come from the manufacturer itself. So if I've got a scenario and I've got 500 of some type of devices from a single manufacturer, that manufacturer may have their own platform that connects to their different devices and some others to pull that data. But unfortunately, the OEMs are not there, but the software is bringing that to bear.
In terms
Yes, sir.
of IoT devices and sensors to place on machines to detect whether they're operating or whether they need to be serviced, how is that going?
So I didn't catch that. Can you?
Sensors that you would place on machinery to detect if they're functioning properly or if they need service.
Yes. So what happens is it's a combination of those technologies to come together to find what you're looking for. So there are companies that focus on failure modes, okay? Failure modes of all different types of devices. Because the challenge is you don't want to find out a machine is not functioning improperly when you realize it's functioning improperly. You want to figure out ahead of time that it's going to be functioning improperly, right? So I'll give you an example. If I got a motor, and this motor has a ball bearing, And when this ball bearing emits a certain frequency, that says I got about 3 weeks before this motor is going to fail. Okay? Now, at 1 week out, it's rattling. I know it has an issue. At 2 weeks out, it's starting to run a little bit hot. But I want to detect that ball bearing, which gives me 3 weeks to do something before I have a situation. Right? So there are sensors that will detect that frequency, tell me, hey, you got 3 weeks, and now I can take this thing down. Right? So combinations of those sensors and understanding what those failure modes look like for different devices, there's a whole market for that in terms of the preventive maintenance space, being able to predict that I'm going to have some type of outage. Right? And again, you can measure this in human people, right? Because some of those outages are huge and people die and things blow up and that kind of thing. So that whole space is a very important space. But additionally, making sure that I can bring that machine down on a scheduled time versus having some type of outage and now I'm losing money. Anything else? I got a few more minutes left. Okay. Well, thank you very much. Really appreciate your time.